Binary search is an efficient algorithm used for finding a specific element within a sorted array. It works by repeatedly dividing the search interval in half. The algorithm starts by comparing the target element to the middle element of the array. If the target element is equal to the middle element, then the search is successful. Otherwise, the search interval is reduced to either the left half or the right half of the array, depending on whether the target element is smaller or larger than the middle element. This process is repeated until the target element is found or the search interval is empty. In step 1, beginning is the lower bound, end is the upper bound. Mid can be identified through adding beginning and ending and dividing the sum by 2. In step 2, we repeat the step 3 and 4 by using a while loop. Here in the loop it checks whether beginning is lesser or equal to end. In step 3, if the value of item is lesser than the data of mid, if the condition is true, it will execute set end to mid -1. If the if condition is false, it will execute beginning to mid +1, and the if loop will close is here. In step 4, we will set mid to the integer value of beginning plus ending and dividing the sum by 2. In step 5, we will open another if statement by the condition as data of mid is equal to item. If it is true, the value of mid will be transferred to location. If the condition is false, the value of location will be null.
Binary search is a search algorithm used to find a value within an already sorted array. It works by continually halving the subarray that it is considering until the value is found or it is determined that it does not exist in the array. To achieve this, it maintains 2 pointers, a left pointer and a right pointer, from which the middle position of the subarray can be calculated. We can check this middle position against the value we are searching for to determine if it is the same, higher or lower. When sorted in ascending order, if the middle position is lower than the value we are looking for, we know that the value, if it exists, must be in the subarray to the right of the middle value. Similarly, if it is greater, the value must be in the left subarray if it exists. Of course, if it is the same value, then we have found it and can return. We continue these previous steps, moving the left or right pointer to the beginning or end of the next subarray respectively, until either the value we are looking for becomes the middle position and is found, or there is nothing left to search. Since each subarray is halved until termination, this algorithm has a time complexity of O log n time.
Introduction to text line length adjustment. Text line length adjustment is the process of adjusting the length of text lines to fit within a specified width, ensuring readability and aesthetics. Text line length adjustment operations: adding text, inserting new text to fill gaps or complete sentences. Removing text, deleting unnecessary words or characters to fit line length. Word wrapping, breaking text into lines at word boundaries. Line breaking, inserting line breaks at strategic points. Text justification, aligning text to left, right, or center. Hyphenation, breaking words across lines. Step 1, start. Step 2, read the string and store it in str. Step 3, read the line width limit and store it in line width. Step 4, find the length of str and store it in strlength. Step 5, declare the variable I, k and counter. Step 6, declare the output array output to store the result. Step 7, set I equals 0. Step 8, while I, strlength, do the following. A. Copying string to output. For counter 1 to line width, do the following. I, if I equals to strlength, then assign null character to output, I, and print the output. 2. Else. Assign str, I, to output, I, and increment I by 1. B. Handling space. If str, I, is a space, then assign end-of-line character to output, I, and increment I by 1. C. Handling word split across 2 lines. Backtrack to the previous space character and the end of line should be added at that location. Assign I to k, i.e., k equals I. While k, 0, do the following. If str, k, is a space, then assign end-of-line character to output, k. I equals k plus 1. Else, decrement k by 1. Step 9, end.
So if I have text string of size 16 and pattern string of size 4, then I need to take a window size of 4, which is the size of pattern string. Now we start running the window over the text string starting from index 0. This is the window in text string Then we compare this window with the pattern string, and if both these strings are found to be equal, then we say that the pattern has been found at that particular index in text string. Then we move the window forward and again compare the window with the pattern string. Similarly, we keep moving the window until we reach to the last window. This is the last window in text string. So we see that if text string size is 16 and the pattern string size is 4, then the last index where the window should be there is given by 16 minus 4, that is 12. So the window runs from 0 to 12.
Introduction to keyword searching in text. String matching. Keyword searching involves finding occurrences of a specific word or phrase within a larger text. This process is often used for tasks like document analysis, information retrieval, and web search. Pattern recognition. Keyword searching is essentially pattern recognition. The algorithm looks for instances where the specific keyword matches a sequence of characters within the text. Efficiency. Various algorithms are used for keyword searching, each with different performance characteristics. Some algorithms are faster than others, depending on the size of the text and the complexity of the search pattern. Step 1. Start. In Step 2, read a text and store it in the array str. In Step 3, read a pattern to be searched and store it in the array pattern. In Step 4, set str length equals strlen str. We are assigning the value of strlrn of string value to strlength. In Step 5, set pat length equals strlen pattern. We are assigning the value of string length to pattern length. In Step 6, declare the variables I, j, count and initialize the value of count to 0. Step 7, for I equals 0 to str length, pat length, do. For j equals 0 to pat length, do. If str, I plus j, equals pattern, j, then break. Step 8, if j equals pat length, then display the position I plus 1 as the position of the pattern that has been found. Count equals count plus 1. In Step 9 it will display the output of count values. In Step 10 it will end the program.